Alright guys, this is the key to the chapter 9 practice test. Let's get into it. So simplify the following expressions, circle your answers. So first one, we got root 27 x to the fifth. So we can simplify this to root 27 times root x to the fifth. And we think about, are there any perfect squares inside of 27? Well, 9 goes into 27, right? So we could split this up into root 9 times root 3. And so this is just 3 root 3. So we're good with the root 27. With the x to the fifth, when it's a variable with the exponents, you actually want to split this up into an even exponent, the highest even exponent, and then the one that's left over. So root x to the fourth is just x squared, and then root x is just root x. So they were done. 3 root 3 x squared root x would be your answer. Okay, over here it's the same thing. This, we're just going to square root everything top and bottom, right? This is the same as root 25 x to the 6 over root 36. Well, root 25 is 5, root x to the 6 is x to the third, and root 36 is 6. That's it, 5x cubed over 6. Remember that when you square root an exponent, you're really just dividing it by 2. That's why we end up with the 3, why 6 becomes 3, because you divide it by 2. 3 root 6 minus 2 root 24. In order to combine these, we have to have them written in the same radical, the same square root. And right now they're not, right? One's root 6 and one's root 24. So we cannot combine these right now. But what we can do is simplify root 24. We can rewrite this as, well, the biggest number that goes in there is actually, biggest perfect square is of root 4. So root 4 times root 6 here. And so when we simplify, we'll get 2 root 6 minus 2 times 2, right? Root 4 is just 2 times root 6. So we have 2 root 6 minus 4 root 6. 2 minus 4 is negative 2 root 6. Okay? All right, 4 and 5. 5 over root 7. You're not allowed to have radicals in the denominator, so we're going to go ahead and multiply by root 7 over root 7. And we're going to get 5 root 7 over 7. And that's it. That's all I can do there. Here, again, not allowed to have radicals in the denominator, but when you have a mixture of terms like this, you multiply by the conjugates. It's 11 plus root 3, root 3 plus 11 on top, and root 3 plus 11 on bottom. Let me say it again. Root 11 plus 3 on top, root 11 plus 3 on bottom. When we multiply across, we'll get 2 root 11 plus 6 over, and then at the bottom we can multiply this out in a box. Root 11 minus 3, root 11 plus 3, we get 11 minus 3 root 11 plus 3 root 11, and then minus 9. These will cancel, so it's just 11 minus 9. Of minus 9 is 2, so we have 2 root 11 plus 6 over 2. We can simplify this by dividing both of these by 2. Our answer is root 11 plus 3. Okay? For 6 and 7, use the graph to solve the equation. So the idea here is you're just using the graph, right? There's no algebra, like analytic algebra here. It's just using the graph to answer the question. So if we got this to equal 0, we do x squared plus 5x plus 6 equals 0, and this equation is what is being measured here. So to answer this question, we just need to know where this equation hits the x-axis, right? And that's happening here at x equals negative 2 and x equals 3. This is just looking at the graph and looking at the x-intercepts. This one, same idea. Where does this equal 0? Where does it hit the x-axis? Right here at 1 and right here at negative 4. Those would be your answers. So that's pretty straightforward, right? Just look for those x-intercepts. Okay, next we have sort of the meat of the test, which is all about the three methods. So we have factoring, quadratic formula, and complete the square. And you must use one of each method and be prepared to use them right throughout. But you've got to use each of them at least once. So let's go ahead and start with a factoring. I'm choosing factoring because this one is, it's already set equal to 0, and I can find two numbers that multiply to get 10 and add to equal 3 pretty easily. That's going to be 5 and negative 2. So my factors are x minus 5 and x minus 2. Sorry, x plus 5, x minus 2 equals 0. So your solutions are x equals negative 5 and x equals 2. My method was factoring. My explanation is like it was already set equal to 0. So that was kind of straightforward, and line 8 was 1, so it was straightforward in both those ways. Okay, let's look at 9. I'm actually going to factor again. I should mostly factoring. Let's try factoring on this one. So factoring would say, let's do ACB. 2 times negative 1 is negative 2. Negative 1 bottom. 2 numbers that multiply to negative 2 add to 1 are negative 1 or negative 2 and 1. So we're going to split up 2x squared minus 2x plus x minus 1. We're going to take out 2x. So 2x on the left side, then x minus 1, and then x minus 1 here. So our factors are 2x plus 1 and x minus 1, right? Because there's this invisible 1 right here. So your solutions would be x equals negative 1/2 and x equals 1. So we factored and we used that ACB method. Okay. Let's try something different for the next one. We've done 2 factoring. Let's do some quadratic formula. So these ones down here, I'm questioning whether or not you could even factor this one. So that's part of my questioning. We still need to set these equal to 0 before we use quadratic formula. Let's do it though. 3x squared plus 6x minus 4 equals 0. And then I'll just write it. Remember, don't forget the song. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And we'll plug it in. So we'll get, so don't forget a equals negative 3, b equals 6, and c equals negative 4. So it would be negative 6 plus or minus the square root of 36 minus 4ac. So 4 times 3, 12. 48 over negative 6. So just, by looking at this, I can see that it's going to be no solution, right? So we use quadratic formula, and we see there's no solution here because this is a negative, right? So therefore, it's a no solution. Okay, because if you get a negative value in the square root, it has to be no solution. Okay, let's do another quadratic formula. Hopefully this one works out for us. So it's just, this one we could actually solve in an easier way. So notice that we just have a squared term here, and we have no x term, so we can actually just solve this one for x squared. So we have 2x squared, we're going to minus 6 both sides, equals 8. X squared equals 4, so x equals 2 and x equals negative 2. So this method would be just square root. Explanation, no bx term, right? There's not that middle term, so you can solve it. So we can get x squared alone. Okay, let's do some complete the square. We've done some quadratic, we've done some factoring, let's complete the square. So this one's kind of already set up to complete the square, let's do it. So we're going to add b over 2 squared to both sides. And that's going to get us 9 over here, x squared minus 6x plus 9, and then a 1 on this side. Then we're going to rewrite that as x minus 3 squared equals 1. We're going to square root both sides. We're going to get x minus 3 equals 1 and x minus 3 equals negative 1. So x equals 4 and x equals 2 are my answers. Let's just complete the square. Okay. This one's already set up to complete the square. We just have to finish it. So we're just going to minus 3 both sides. x minus 1 squared equals 9. We're going to square root both sides. We're going to get x minus 1 equals 3, and x minus 1 equals negative 3. So x equals 4, and x equals negative 2. Okay, so this is a complete square. And then the last one here, we can do whatever we want, right? We can do factoring, we can do... Hey, so
No, I understand.
for this last one, we're going to do factoring. So two numbers that multiply get 12, add to get 8. That's just going to be 6 and 2. So x plus 6, x plus 2. Our solutions are x equals 6, x equals negative 6, x equals negative 2. That's factoring. All right.